Welcome to the Surreal Life. In today's video, we're going to take a deep dive into SurrealDB, a brand new database written in Rust that has a feature list that goes brr. If you watch my 100-second video, you'll know this database has pretty much every feature that modern developers want, but it almost feels too good to be true, so what are the trade-offs? I asked on Twitter, and Jamie, one of the co-founders, responded that performance improvements around indexes are coming very soon. What that translates to in Primeagen speak is that as of today, it may not be as blazingly fast as you would hope. I don't have any benchmarks on my person, but when it comes to databases, there's always a trade-off to be made. There's a whole thing called CAP theorem that real backend developers have to think about. Another interesting point is the license. Its core is actually not free and open source software. It's under a license that basically prevents big cloud providers from taking their software and monetizing it. But interestingly, it reverts back to an Apache license after 4 years. Personally, I think that's very reasonable. And the final potential drawback is that it's a very new product, and a lot of the tooling is not quite there. Like, there's not even a VS Code extension at this point, but all that stuff is on the roadmap and will come eventually. One nice thing currently is that it's not VC funded. It's just bootstrapped by two brothers, and they have plans to monetize it with a fully managed cloud service. I wouldn't blame them for taking VC funding, but I hope it stays independent because I've seen the grow or die mentality kind of spoil a lot of open source projects that could have done really well on their own organically. And SurrealDB looks exceptionally amazing. Let's jump into the code and I'll show you why. First, you'll need to install it, which is very straightforward on every OS and can also be done in Docker. Next, you'll need to think about how you want to run your code, which can be done in a variety of ways. You can use the Surreal SQL command to run it in REPL directly in the terminal, or it has a variety of client libraries like JavaScript and many others on the roadmap. What I'm going to do though is use its built-in REST API. To do that, you'll want a REST client like Postman or Insomnia, or the Thunder Client VS Code extension as I'm using here. Before we jump into it, make sure to start up the database by going to the terminal and run the Surreal command with a root user. Now in your REST client, create a post request to the SQL URL. It'll need to have headers for the database namespace and can also use basic auth with your username and password, which should be root. And then finally, for the body, we can send text, which will be the raw SQL code. The first thing we'll want to do is create some data. I'm going to create a bunch of humans and then create a bunch of weird relationships between them along with other objects to show you how relational queries work. By default, data is schemaless, which means we can basically add whatever we want to the database without any restriction. That's mostly nice for prototyping, but can also be useful when you have unstructured data with different properties that might change on the fly. Use the create keyword to create a new record. Now at this point, it becomes important to understand how IDs work in SurrealDB. Every record has an ID that's broken up into two parts. On the left side, you have the table that record belongs to, and on the right side, you have a unique ID. You can define the unique ID yourself when creating a record, but if you leave it out, it will just be randomly generated by the database. Now, after the ID, use the set keyword to define different properties on that record. In the last video, I put sex equals true, and a lot of people tweeted at me thinking this was some kind of political statement about the gender debate. But the reality is that it was just an immature joke about boning.
Sex? Yes, please.
Now go ahead and click send to send the request, and that should create the record in the database and then return that object as a response. I'm going to create two humans here, Jeff and Chad, and now we can query this table to get all of the records using select. Select feels just like it does in a regular SQL database, where you can also select specific values from a table, and you can also write a where clause to filter the results by a condition, like greater than a certain age, or limit to limit the number of results. That's cool and all, and there are a ton of other features I could talk about, but what's really surreal about this database is that it seems to have the best of all worlds when it comes to relational data. You can use it just like a document database like MongoDB or Firestore to embed things like arrays and objects directly on a record. For example, if we want to create an embedded one-to-many relationship where every human has a set of skills, we can easily do that with an update statement that will add this array that contains breathing and walking in it to every record in that table. This is what you might call a denormalized pattern because all the data is contained in a single location. What's cool about this database though is that we can also model in a normalized way with the same mental model as something like Postgres. For example, if we want to create a one-to-one relationship where a human has one best friend forever, we can do that by updating Chad with the BFF property of Jeff. That's nice and simple, but things get dramatically simplified when it comes to joining data. If we wanted to fetch the data for Chad's best friend forever, we would need to do a join in an SQL database based on the foreign key stored there. Now in SurrealDB, every record has the name of the table that it's stored in, so we can fetch related records records by simply referencing what we want with dot notation. It's just extremely intuitive. You've got the normalized data models of SQL with highly simplified data fetching patterns like NoSQL. But now let's see if that holds true on more complex relationships. Let's create a one-to-many relationship by adding a new table to the database named cars. Chad owns both a Tesla and a Jeep. Chad can own many cars, so we can set up that relationship as an array of record links on his record. But on the other side, a car belongs to a user, and we can solidify that relationship by adding an owner property to each car. I'm going to go ahead and run the code as is, but in real life, you'd likely want to run this in a transaction so all the writes can succeed or fail together. And SurielDB is fully ACID compliant, by the way. Now, we have two different ways we can query this data. We can select all the cars from the Chad record, or alternatively, we could select all of the cars where the owner equals Chad. Still very simple and flexible. Let's make things more complex by assigning many parts to every car. We first create the park records, then update each car record to link the appropriate parts. But now, what if we want to make a query to get all of the car parts that Chad owns through his cars? What we just created is a has-many-through relationship, but it doesn't need any joins or intermediate tables like you would in SQL. In fact, we make a query just like we did in the previous example using dot notation. You can use dot notation as many levels deep as you want. I have no idea what the performance implications are, but you can basically traverse your entire database through these record link relationships. Now, if that weren't enough, you can also add graph edges between these records. If you think of all the records in your database like entities or nouns, then relationships are more like actions or verbs. For example, if we're building a ride-sharing app, we might want to keep a record whenever somebody drives a car. A relate statement allows us to do that in a very intuitive graph database kind of way. What you do is use arrows to point between an alternating set of nodes and edges. In this case, Chad drove the car Jeep. The edge is just another record, and you can set data there as well, like the time and destination, which of course was the club. Now, Chad also let Jeff borrow his Jeep to take to the library, so let's create that relationship as well. Now the question becomes, how do we query this data? Well, we can actually just use the same arrow syntax. Like if we want to figure out all the humans who drove a car, we can select from the human table, then point to the drove relationship, which then points to the car that was driven or driven. On the other hand, we might want to get all the humans who drove a car. We can do that by selecting from the car table, but this time we'll point the arrows in the other direction to get all the humans who drove the cars. Now, to understand how this works a bit more, let's go ahead and select everything from the drove table. What you'll notice is that we get a collection of records back, the only difference being that they have in and out properties that point to other records on the graph. Now, there's a ton of other features in SurielDB, but I think what makes it really special is the way it handles relationships. I've never seen an API that's both this flexible and also this easy to use at the same time. I haven't tried everything though, and I'm looking forward to checking out EdgeDB and Zada or Exada or Zeta, just to name a couple that are high on my list. That's the end of this tutorial. If you like this beyond 100 seconds format, like the video and let me know in the comments. Thanks for watching, and I will see you in the next one.